Hi, welcome back. Now let's get a bit technical. So as we have begun, we are dealing with how to plot a graph, and through that we have seen the finding the gradient of a line, right? So we are dealing with how to plot a straight line. Now from there we have seen how to plot, knowing the coordinates, and then we have recently been introduced to finding the gradients, and then with the gradients we learned the gradient is of the form or an expression y is equal to mx plus c. Now we realize that the m there is the gradient, that is here, right? So the m is a gradient. And then in this episode, right, we are building the blocks like we have said always, and then like before, that we are building the blocks. Whatever you learn, we are not discarding that. We are building that concept or understanding up. So it means that if you don't understand a previous topic, don't continue. In fact, you will get confused. And this particular topic, henceforth, is going to be a bit of more technicality, right? It's going to be more technical. So I'm going to take my time in as much as possible to make sure that things are made easy, right? Because the terms, and in fact, basically, we are going to deal with the difficulty will only arise from the substitution. In as much as substitution is very simple, if you don't know which item or which variable to substitute for what, that is where the difficulty comes in. So please pay attention whilst I explain this. So with a gradient, we know that the gradient is the slopeness or the steepness of a straight line. Now we got a formula to be y2 minus y1 x2 over that's x2 minus x1. So that's what we got. Now don't get it twisted. It can also be y1 minus y2 over x1 over x minus x2. The same way y minus y1 x minus x1. So what it means is that it's based on the one solving the problem, the student, or the one solving the problem. So the one, if you choose the coordinate beginning with the y2, then the denominator here also should be y2, so that it should go hand in hand. I mean vertically, literally, just for simplicity, it should be that way. So y2 x1 x2 y1 x1 y1 x1 y2 x2 y x x1 x2. Now in practice you realize or you understand what I mean by this, because that is where the confusion comes. If you don't substitute them correctly, things will get messy and difficult. So for starters, we know that the y is equal to mx plus c. So the m is a gradient. So that's what we are going to go to look at. Now in this topic, right, the main focus or the subtopic is finding the equation of a straight line. That is what we are going to look at. Now, finding this one, it means that whatever we have learned so far, the understanding or the items, the elements that we deliberated on them, we have to apply them here. So if you do understand them, you can apply them here. Now, for the record or for starters, there are a number of items or elements that we will need in two situations. So in one situation, the items that will be needed is what? The gradients and a point on the line. That is it. And then there's the second situation is when we have 2 points on the line. Now, what points are we talking about? On a graph, there are a number of points on a graph. For instance, here we have point A and point P. We can even have point Q or point C anywhere. It's just a point. So the point is where we have the coordinates, the x and the y. That is what it means. And this one, we are saying that for situation 1, we will need a gradient and a point. So a gradient and a point is enough to find the equation of a line or a straight line. Now in the second situation, we will need 2 points. So meaning with or without gradient, we can still find the equation of a straight line. So with that being said, with that well understood, let's look at the first situation. Now, the first situation here is the better expression. We are saying that to find the equation of a straight line or a line given the gradient m and a point A, x1, y1 on the line. This is it. So it's an assumption, or it's like a formula that we are going to derive. If you are able to understand how the formula is derived, then everything will be easy. In as much as this is not an e-math, which we will look at it later, if you should get the concept, how things are established, it will be better for you. You have an upper hand in this concept. So here you can see that the point A, it has been expressed or given, say x1 and y1. So this is what the textbook is saying. So it means that this is what AKI-OLA or Peter Siedu intended to use, the point that he intended to use. So in another fashion, you could be using point B, and then the coordinate will be x, not x1, and then y, and not y1. So it depends on what you have and what you choose to get it. So that is it. I will still explain a situation whereby you will know which one the point to use and which one not to use. But here, because we need a gradient and a point, this is what we are talking about. Now look at this graph. We have point A, which is x1 and y1, meaning the lines from the bottom going up. This is a positive gradient, right? And then we have P, which is x and y. Now the change in y is here, y2, y1, which is expressed here in these short dashes, giving it what the change, right? So y minus y1, right? Good. Now let's move to the x. Yes, x is here, so x1 and this. So this is expressed this here, right? So this is the coordinate basically, and this is the coordinate, right? Now let's come down. What it means is that we are deriving the equation of a line, a general formula. So what I showed earlier, that the linear function of a straight line is of the form y is equal to mx plus c, is a general expression. Now we are looking for the general equation of a straight line given the gradient and a point. So that is what you should take into consideration or put at the back of your mind. So here, if you have here, we are saying that then the gradient of AP is m. Now the gradient of the line is given by, which we know, so y minus y1, x minus x1. So this is what we intend to use. So now we are not seeing y2 and x1 and x2, because this is what we have been given, and then we intend to express it that way. So that is it. So what it means is that if you are sticking with the first y's, stick to that. If you are sticking with the second y's or second x, stick to that. Because if you interchange them correctly, you will get it. By a situation whereby you put x1 here, and then where you need x2 or x, then you interchange it to another x, you get it wrong. So if you are dealing with the one subscript, deal with the one subscript, the two subscripts, deal with them. That is it. So now the gradient of a line is given by y minus y2, y1, x over x minus x1, which is the m. So expressing it again, right? Now we want to get this particular expression, right, on one side. So meaning we are making it the subject of the equation. So that's the idea. We told you substitution has to do with making an expression or a variable the subject of the equation. So with the general formula of a gradient, which we have already looked at, y minus y1 x over x1 is equal to m, we want to make y minus y1 the subject. So this is it. Hence this is what we have. So generally, when we are dealing with equation of a straight line giving the gradient and a point, this is the general formula, right? So with this example, we do the substitution. Here, pause the video. I'm running out of time, so pause the video and put the variables in, do the substitution, and the answer will be correct, right? Now in the second one, where we will deal with the second situation, 2 points on the line, I will explain to you probably with examples. I'm running out of time here, so I hope you understand. If any difficulty in the comment section, let me know and I'll get back to you as soon as possible. Thank you very much for watching. Please like, subscribe and share. Ciao for now.